National Board Certified Teacher.
My journey.
A shout out to Caleb, sent me this email, wanted to know about what I thought about his taking the sample exercise questions for the Math AIA National Board Component 1 questions. So, I guess he started with exercise 3 was the data analysis and stats question. So, you were given all these times, construct a box plot, choose the best measure of central tendency for this data, and identify its value. Use statistical reasoning to explain why this measure would be best single number description to summarize this data point, explain under what circumstances a different measure of central tendency would be a good descriptor of data. So let's take a look at Caleb's work. Okay, so I like the graph. Increasing by 0.25s. I guess you could use your calculator, trying to evenly space as much as possible. 5-number summary, min, quartile 1, median, quartile 3, max. Okay. He finds the average. Okay. This question is, you got 90 minutes, 3 questions, so 30 minutes a question. The stats question has a lot because you have to do both math and writing and explanation. So I think that's fine, but if you had more time. So description of the graph, the numerical analysis here is because the distribution of the sprint times is skewed to the right. There's nothing to the right. Most of the data is to the left. It's positively skewed. The median, 12.1 seconds, is more appropriate measure of center than the mean, which is 12.38. If the distribution of sprint times were more symmetric, the mean would be a better measure of center. So I like it. I'm thinking between if this is one question or this just one part, between a 3 and a 4. I'm leaning towards like a 3. Just because, maybe an explanation that the mean is easily swayed by extreme values and the median is more resistant. Yeah, you can also explain what that max value does. That's the extreme value, possible outlier. You can show that, 1.5 IQR greater than quartile 3. But I like the graph work. Remember, you have to think about, if each of these components, like that's 10 minutes worth of work and you're writing it all out. So nicely done, Caleb. Number 2, let's see what we got. Okay, so you are given in number 2, you're given these scatter plots. You must address the following information in the prompt. In graph A, which of the 3 basic types of relationships between X and Y yeah, so you're saying that this graph over here is a negative linear relationship between X and Y variables. I know this because as the X values increase, the Y values decrease. You're going down. Okay. I think that's fine. If you had time, or you could mention, the points sticking together by the correlation R value. Okay, next one, use your answer above, sketch the scatter plot reversing one of the other types of relationships and state the type. So you gave us a positive linear relationship because the X value increases, the Y value also increases. Okay. They haven't introduced the word yet. You can also mention the best line of best fit. shows a positive slope, positive y-intercept. Let's see. Except for one point, the graphs on graph C are the same of graph A. How would a line best fit on graph C compare with a line best fit on graph A? I like this answer. You're basically just saying that it's lowering the y-intercept. Right, if the line's going this way, take it out. The y-intercept may not change as much, but definitely the slope. Yeah, that was a good response. And the last one, compare the correlation of the data in graph A with the correlation in graph B. Choose your rationale. So this is tighter, this is closer. So you talked about a correlation closer to -1. You're showing it's weaker. You know, you can even be as bold as letting us know, like, maybe a number that you think the R value might be. I think that would be fine too. Okay, so that was exercise. Okay, we're still under exercise 3. This is now prompt 3. So you have the number of ounces in bags of chips is assumed to be normally distributed with a mean of 16 ounces and a standard deviation of 0.5. Find the probability that the bag of chips weighs more than 16.1 ounces. Provide a graph of the normal distribution for the curve. Shade the relevant region and indicate the coordinate of the mean and the coordinate of any endpoints of the relevant region. Okay, so again, you know, if you have an exercise 3, 30 minutes, the stats problems I think take a long time. And you're basically, you know, Caleb did all that in 10 minutes, all of this in 10 minutes. That's pretty much like 2.5 minutes, which is a lot of work to do. So good job. But this one, I think you're running out of time. You know, on the x-axis, I like showing the ounces. And then I also like showing the z-scores. I also would have liked seeing on the intervals, you know, you're just counting, you know, you have it by 0.5. So I think that would have been nice if you're showing us that the standard deviation is 0.5. So just counting by 0.5s would have been nice. Nice, normally distributed. Mean is 16 and standard deviation of 0.5. I always like writing the formula first if you had time, but you didn't, which is okay. So you're showing us the score minus the mean divided by the standard deviation. So you have a z-score of 0.2. Then you're finding the probability that's greater than, which means a z-score that's higher than 0.2. Nice. You're showing us 1 minus the number. Perfect. And a sentence explaining it. I think that was sufficient. Yeah, I think I lean towards a 4 on this one, but you know, maybe more details on the graph if you had time. Again, that was pretty hard. Okay.
My journey.
I love you, Daddy.
I'm Mr. Ing's mom. Do your homework.
I married a math teacher?
I'm the original Mr. Ring.